kind of join me in the chat, you're welcome to watch it anytime. And once I find the link for that stream, I'll post it in the chat here. Just an old dude who has to figure out how to get the link.
Did you already start it?
Yeah, the stream started, so actually if you subscribe, you'll probably...
Copy the URL at the top and then put it in Google Classroom. I'm pretty sure that's how it works.
Alright, thanks.
Just copy that at the top, like in the search bar.
Yeah, so I stream off a platform called Open Broadcasting System, which is like embeds within YouTube. So
you're not using YouTube?
Yeah, it'll stream. It'll be hosted through YouTube. Oh, Michaela's here too, actually.
Oh, somebody new joined.
Yeah, how you doing, Michaela?
Good.
I'm sorry I was late sending the link out. Michaela, if it's okay with you today, I'm gonna switch this to just a link that's on YouTube that you can watch me there. Or would you rather we just do this on Zoom the regular way? Oh, TN's here too.
Okay, I'm missing school. I'm trying to go outside. I'm stuck in this house.
Yeah, I'm sorry you're stuck inside. TN, how you doing? Welcome.
It's not hot.
Alright.
I'll be right back. I got water.
Oh, Jamari Mathis is here too. I think we're still gonna run with that. Jamari, how you doing, man? Cut this meeting in a second so I can start running that broadcast.
Jamari.
Follow the link and I'm gonna post it on Classroom too.
Jamari, I got you.
Jamari, how you doing, man? So, Jamari, if you look in the chat window here, and I'm gonna post this on Google Classroom too. Instead, I'm gonna kind of run this lesson just broadcast. It's gonna go broadcast. Alright, so I think for YouTube I have some of you here with me. Let me just find that. How you doing, Marcos? Alright, so I think for YouTube I have some of you here with me. Let me just find that. Alright, so thank you for those of you who are able to join us here on YouTube. If you are with us live and you want to chat, feel free to use the chat function or the chat box that you see there on YouTube. Alright, so today's lesson, we'll zoom in a little bit on the screen, but today's lesson is focused again, like we were on Tuesday, on working with inequalities. Specifically, the lesson is going to focus, as you can see, on how to solve those inequalities when they start to get a bit more complicated. Our big focus is what's listed here for question number 2. Our big focus, our big goal today is how do we use those inverse operations, addition, subtraction, multiplication, and division, the opposite operations, to be able to solve inequalities. Take a look at problem number 1 now. Problem number 1 asks you to consider the following inequality, and the inequality that we have listed there, it says 4, this symbol says 4 is less than 10. That's what that's telling us. So this is a true statement. It is true to be saying 4 is less than 10, and we're going to change this inequality by doing different math operations. They use this word transform to mean change. So we're going to change this inequality by doing the same thing to both sides and see what happens. The first thing they say is to add 5 to both sides of the inequality. So 4 plus 5 would be 9, and 10 plus 5 would be 15. So if we were to add 5 to both sides of this inequality, it would say 9 is less than 15. That's something that's still a true statement, so it does tell me, hey, I'm allowed to add the same number to both sides of the inequality, and it would still be true. For the second box, they ask us to go ahead and subtract 3 from both sides of the inequality. So if we were to subtract 3 from 4, and Michaela, good to see you saying hi in the chat box. If we were to subtract 3 on both sides, we get 1, because 4 minus 3 would be 1, is less than 7. That's what we'd get with 10 minus 3 on the right side. And that would still be a true statement. 1 is less than 7, so we see if we subtract the same number on both sides of the inequality, we end up getting a true inequality. So if I divide 4 by 2, I'm going to be at 2. And if I take 10 and I divide that by 2, I'm going to be at 5. So if I were to divide both sides of this inequality by 2, the statement would now say 2 is less than 5. That's also a true statement, so we see, hey, we can divide both sides of an inequality just like we can divide an equation. The very last one says to take both sides of the inequality and multiply by -2. And Daniel, good to have you joining us. Thanks, buddy. So if I multiply both sides of this inequality by -2, 4 times -2 becomes -8, and 10 times -2 becomes -20. But something happens here. If we keep the symbol the same, if we leave this as a less than symbol, the inequality is going to be trying to tell us -8 is less than -20. So -8 is actually larger in value, or as Christella said on Tuesday and Wednesday, it's closer to 0 than -20 is, so it's larger than -20. So because of that, we learned something very important here, and I'm going to summarize this in the rules. Whenever first off, we can use inverse operations to solve inequalities. A lot of the inverse operations that we did to solve equations for the 2 weeks before April vacation are going to help us out a lot when we try to solve inequalities here. So our goal is going to usually be to get the variable all by itself, and we can do the same thing on both sides of the equation. But there's one important trick. If you multiply or divide by a negative number, the sign has to flip for the inequality. And we'll give that a second to type up and show up. So a big thing to recognize, and we saw this when we multiplied by -2, you're allowed to do the same operation to both sides of the inequality to solve, but there's one new rule, which is if you multiply or divide by a negative number, because you're taking the entire opposite of the equation when you multiply or divide by a negative, you have to flip the sign. So with that in mind, we're going to go into now solving some inequalities, getting the variable all by itself, so we actually know the solution set to the inequalities. The first one, and I'm going to go ahead and make my whiteboard larger here as we work through. The first one says -36 plus x has to be less than 8. So if that's our inequality, our goal, just like when we solved equations, when we solve inequalities, our goal is to get the variable, in this case the x, all by itself on one side of the equation. I'm going to use inverse operations. I see that the x is in the left expression over here. I want to get rid of the -36. And to get rid of the negative 36, I'm going to add 36. That's the inverse, or the opposite, that cancels out negative 36. I'm also going to add 36 to the right side of the inequality to make sure that it stays true, it stays balanced. So I get x is less than whatever 8 plus 36 is. If 10 plus 36 would be 46, then 8 plus 36, 2 less, would just be 44. There's a few ways we can do that mental math or figure out what 36 plus 8 is. It gets us to 44. And so our first solution says x needs to be less than 44. And you see the work there on the whiteboard. If you're at home, I don't need to see a whiteboard for all 4 of these problems on number 2. 1 or 2 pictures of your work is more than fine to show, hey, we've been working through this step by step. So the next one, I got to make the whiteboard a little bit smaller. The next inequality we have here that we're going to solve says y plus 5 is less than or equal to negative 4. So again, our goal whenever we're solving inequalities is to try to get the variable isolated, to get it all by itself on one side of the inequality. And my goal here, or what I need to recognize, is I want to get the y all by itself. It's on the left side of the inequality over here. So I'm going to subtract 5 because that's the inverse operation of adding 5, or the operation that would cancel out the positive 5. That now gives me y is less than or equal to negative 4 minus 5. Whenever I combine or subtract with 2 negative numbers, I just add them up. 4 and 5 makes 9, and I keep the negative sign. Negative 4 minus 5 gets us to negative 9. So if y were anything less than or equal to negative 9, then that inequality would be a true statement. Now, if you want to put that less than or equal sign, there's 2 ways. One, I could just go copy it from the other inequality up here, so I'm going to hit Command C and put that in there. And also, if you're following along at home, I got to open the menu up for a second. But if you're following along at home and you ever want to put your own inequality sign in there, what you need to do, I'll delete all of this, is you insert an equation. So I click on this insert menu. I click equation. It's got that little pi squared symbol next to it. And this equation allows me to put some of the fancy math symbols in. You're going to see a little toolbar come up right here that I'm highlighting with my mouse. So I'm going to type y, and then in these menus in the toolbar, this one, the third menu that's called relations, it has the inequality less than or equal to sign right there. So in this case, y is less than or equal to negative 9. If you're at home, you don't necessarily need to panic about getting that symbol. You could copy it from here, or if you put the less than symbol, I understand that's what you probably meant. Okay, so then with that, we're going to now keep moving on to the third problem from number 2. And for that, just give me 1 second to shift these whiteboards a little bit, to shrink that whiteboard enough that we can see that problem. Alright, so now the next one says 9m is greater than negative 18. And hopefully if you're at home following with us, you are writing these problems out, even pausing the video, trying to solve some of these on your own, if you're joining us afterwards. So it says 9m needs to be greater than negative 18. Here, I see that I want to, the m is on the left side of the inequality, I want to get it by itself, but this time it's not being added or subtracted with a number, it's being multiplied with a coefficient. It's multiplied by 9. And the way I peel the onion or get rid of these coefficients that multiply with variables, hopefully remember from Mr. Neville, division is the inverse operation that cancels out multiplication. So if I divide by 9 here, that cancels out the coefficient, the multiplied by 9, and leaves us just with m. And we remember from earlier, we can divide by positive numbers and the inequality doesn't flip. Sign's going to stay the same. M is greater than whatever negative 18 divided by 9 makes. A negative divided by a positive always gives us a negative, and 18 divided by 9 gives us 2. So negative 18 divided by 9 yields negative 2. M needs to be greater than negative 2. And that moves us on to our last one, the last one here. Hopefully that makes sense. While I erase the whiteboard, we're now moving on to the final one for number 2. That says 15 is greater than negative 5 multiplied with n. So 15 is greater than negative 5. Oh, sorry, it's less than. 15 is less than negative 5 multiplied with n. We see this time the variable is located on the right side of the inequality. It has a negative 5 multiplied with it, so to cancel out negative 5 as a multiplication, I'm going to use a divide by negative 5. Divide by negative 5. The negative divided by a negative cancels itself out. 5 divided by 5 reduces to 1, so that just leaves us with 1n, or what I'm going to write as n. 15 divided by negative 5. A positive divided by a negative produces a negative. And 15 divided by 5 gives us 3, so this is going to produce a negative 3 as a quotient. A big thing to remember, and this came from number 1, inequalities, the one tricky difference between inequalities and solving equations, whenever you multiply or divide by negative numbers because you're doing the opposite to the entire equation, you need to flip the sign or take the opposite inequality sign. So this won't stay as a less than symbol, it becomes a greater than symbol. So it says negative 3 is greater than n. Or, more likely, we like to refer to the variable first, so I'm going to say n, flipping this, n is the smaller one, so n needs to be less than negative 3. Both of these answers mean the same thing, they're equivalent to each other. This is more standard form to say what the variable is on the left expression. So I'm going to put n is less than negative 3 into my document, and if you had put negative 3 is greater than n, that means the same thing. That would also be correct here. Okay, hopefully that makes sense for how we can solve these one-step inequalities. If you were thinking about your work on Khan Academy, which we'll pull up towards the end here, this is tied directly to that solving one-step inequality assignment on Khan Academy. So hopefully that would help you. You're good to go with that if you haven't finished it already. Next up, we're going to move down to problem number 3 in this document, the bachelor's level problem. And for number 3, so let me get that up there, it says solve each inequality below, and again, insert an image of your work. You don't need to insert an image for all 4 of these equations, just 1 or 2 is fine in the document to show us you were solving these out step by step on your own as well. What's trickier now, you see these inequalities get a little more complicated. There are more terms, more numbers and variables going on in the inequalities, but just like with the equations as they got more complicated, the key is to write this out and move step by step to try to solve for that variable or isolate that variable. Our first one, 8a minus 8 needs to be less than 72. So this is a statement saying 8 times a minus 8, whatever it is, needs to be less than 72. And our goal is, well, what numbers could a be to solve or to be a solution for this inequality? I'm going to solve just like I would with an equation by drawing a river, a line right through the inequality that splits the left side from the right side of the inequality. I see the a is living on the left side of the inequality, so I want to get that all by itself. And if I want to get a all by itself, I'm going to go ahead and first get rid of the negative 8 there. If I were to add 8 to both sides of the equation, when I add 8 to both sides of the equation, that cancels out the negative 8 on the left side. It's the opposite of subtracting 8. That's why I chose to add 8. So my equation is now a little simpler. 8a is the only thing that's remaining on the left side of this equation. I bring the less than symbol down, and 72 plus 8 sums to make 80. Now it's closer to that one-step inequality we were just solving on number 2. If 8a is less than 80, I'm going to go ahead and divide both sides of this equation by 8, because that's how I'm going to cancel out the multiply by 8, or get rid of this coefficient, the 8. Dividing by 8 cancels out the multiply by 8. That leaves us just with a on the left side of this inequality. We divided by a positive number, so the inequality won't flip. It still remains a less than symbol down here. And 80 divided by 8 gives us 10. So that's how we get to a is less than 10. If you're watching at home while I set up the next problem, or if you're recording and joining us after, I would encourage you to pause the video and try to do this next one on your own, or at least figure out the first couple steps before I'm going through them. So the next inequality we have says 11b plus 5 is greater than or equal to 49. So if you're at home, pause the video, try to solve this on your own. If you're with us, be thinking about what would be the first step I'd be doing here. Alright, and so 11b plus 5 is greater than or equal to 49. We notice the b is on the left side of this inequality, so I'm going to try to get b isolated or all by itself on the left side of this inequality. First thing I need to get rid of, or the first layer I'll peel, as Mr. Neville would say, is this plus 5. I don't want that over there. So I'm going to use a negative 5, the inverse operation, to cancel out that positive 5. I'm also going to subtract 5 on the right side of this inequality. 49 minus 5 is going to give us 44. That greater than or equal to sign stays the same, and all that we have in the left expression now is 11b. So it says 11b is greater than or equal to 44. Hopefully you're all screaming at home, Mr. Doherty, we need to divide by 11 now, because that's how we cancel out the multiply by 11. So I'm going to divide both sides of this inequality by 11 to cancel out the coefficient with b, the multiply by 11. 44 divided by 11 gives us 4. So this simplifies to say b is greater than or equal to 4. So again, if I want to type that fancy greater than or equal to symbol, I could copy it, or I could hit new equation. This is the same thing as hitting insert equation. And I could say b, use the menu up here, greater than or equal to, that sign's not flipping when we divide it by a positive. B is greater than or equal to 4 as the solution for that inequality. So there's the work that gets us to b is greater than or equal to 4. We first got rid of the positive 5 by subtracting 5 on both sides. Then we use divide by 11 to cancel out the multiply by 11 and get down to just b is greater than or equal to 4. We're going to transition on to the third question for number 3. If you're at home, I would encourage you to pause this video right now. If you're with us live, be thinking with me ahead of time, what do I want to do first to solve this equation? Sorry, to solve this inequality. So the inequality states negative 2c, negative 2 times c, plus 7 will need to be some value less than 23. As always, I'm going to draw my line, what I call the river, through the inequality, so I can focus what's in the left expression, the left half of the inequality, and what's over on the right half of the inequality. Here I see the variable is only located on the left side of this inequality, the left expression, so I'm going to try to get c all by itself on the left side. To do that, I first need to get rid of the plus 7. If I were to subtract 7, that would cancel out the positive 7. That's the inverse operation I need. So I'll also subtract 7 on the right side to keep the inequality true. That's what allows me to subtract 7. 23 minus 7 gives us 16. So negative 2c is less than 16. Now I want to get rid of the multiplied by negative 2, the coefficient attached to c. So I'm going to divide by negative 2 because division is how we cancel out multiplication. Divide both sides of my equation by negative 2. That changes or transforms the left side to just say C. 16 divided by negative 2, a positive divided by a negative makes a negative. And 16 divided by 2, the quotient, or the answer, is 8. The important thing I need to remember here, if I am dividing by a negative number, I'm taking the opposite of everything in the inequality. So when I do the opposite to the entire inequality by multiplying or dividing by a negative number, I need to take the inequality sign and flip it. So the less than symbol becomes a greater than symbol as a result of dividing the equation by its opposite. So we end up with C is greater than negative 8 for our final answer to that inequality. We're going to transition or move into the final problem for number 3 now. If you need to pause the video, take a look. There's the work that got us there. So we're going to transition and erase that whiteboard now. Our last inequality for number 3 states negative 11 minus 2d needs to be greater in value than 1. So again, I'm going to draw the river, that line that splits the inequality between its left expression and its right expression. I see the variables located over here on the left side, so I want to start getting d, this variable, isolated or all by itself on the left side of this inequality. To do that, the first layer, or the first thing I need to get rid of is the negative 11. I get rid of a negative 11 by using a positive 11, by using its inverse operation. Adding 11 to the negative 11 makes 0. I also need to add 11 to the right side of the equation, and that 1 plus 11 sums to make 12. So I get negative 2 multiplied with d needs to be greater than 12. Now, we want to get rid of that negative 2. It's multiplied with the variable d, so we're going to go ahead and divide by negative 2. Division is the inverse operation of multiplication. That cancels out the negative 2 that's multiplied with the variable, and that puts d all by itself on the left side. I also need to multiply by negative 2 on the right side of the equation to keep, or the inequality, to keep it all true, to keep it balanced. So 12 divided by negative 2 gives us negative 6. And when we divide by a negative number across the entire inequality, we're taking the opposite of the entire inequality. So we need to flip the inequality sign from a greater than to a less than symbol. Gives us a final answer of d needs to be less in value than negative 6. There's the work there. Hopefully that makes sense. We're going to move now to number 4, the master's level, but this one, number 3, was really designed to help you out with the 2-step inequality assignment on Khan Academy this week. So hopefully if you've not completed that yet, if this stuff makes sense to you from number 3, you are definitely ready to do the 2-step inequality assignment on Khan Academy. Moving forward, number 4 has 2 inequalities to solve. They become a bit more complicated, so there's just 2 of them. The first inequality we're going to consider, and I welcome you if you're watching this recording afterwards, or even if you're with us live, be pausing this and thinking, what would I do first before Mr. Doherty shows us his first step? So we see 12p plus 2 needs to be less than negative 5p plus 36. So I'm going to draw a line through that inequality, what I'm going to call my river, that less than symbol. And here we notice what's becoming more complicated now, and you'll see this on what's called multi-step inequalities. It's really a 9th grade Khan Academy assignment. The tougher inequalities to solve as you move into high school will have the variable show up on both sides of the equation or the inequality, kind of like the variable is showing up on both sides of our equations. So what you should recall from solving equations when the variable showed up on both sides of the equation is you needed to get the variable together. So you could combine them. You needed to gather them to the same side of the equal sign. The same is true for inequalities. If I see a 12p on the left side of this inequality, I see a negative 5p on the right side of the inequality, I can't solve it until I get the p's on the same side of the equation so that they could be combined. Here we have two options. We could subtract 12p, and that would cancel out the positive 12p, or we could add 5p, and that would get rid of the negative 5p that's on the right expression. I like positive numbers, so instead of subtracting 12p, I'm going to choose to add 5p. But again, either step would have been fine. By adding 5p, that eliminates the negative 5p from the right side of this inequality. I need to add 5p to the left side to keep everything balanced and true. 12p plus 5p gives us 17p. I bring down the plus 2. That can't be added with the 17p. They're not like terms. And that still needs to be less than the 36 that's over there. And now, by taking that first step, adding 5p and gathering all of the p's on the left side of this inequality, now this looks a lot like those inequalities that took 2 steps that we just solved on problem number 3. I have the p on the left side, 17p here, so I don't want that plus 2 on the side that has the p terms. I want to get rid of that constant, that regular number. So by subtracting 2, that's how I cancel out a positive 2. I subtract 2 from 36 as well, and that gets us 17p is less than 34. So now that I'm at 17p is less than 34, we have one step left. We need to get rid of that multiplied by 17, the coefficient of 17. So we divide by 17. Anytime you have a coefficient with your variable, to get rid of it at the end, we divide to cancel out that multiplication. I divide both sides of the inequality by 17. We're running out of room here, but we'll squeeze it at the bottom. These cancel out, so we have p is less than whatever 34 divided by 17 makes. That makes 2, luckily, or not luckily, but that made a whole number here. So we don't have any additional work to do if we get a whole number there. P is less than 2. I'll show that work on this whiteboard one last time. How we got to P is less than 2. And then we're going to transition into our last inequality for problem 4. Alright, so for this last one for number 4, if you're at home watching this on record a little after us, I would encourage you to pause and try to do this one on your own. If you're with us live, definitely be writing along with me and trying to anticipate the steps before I announce them. So we have 5t plus 3. That's what the left side of this inequality says. And that needs to be greater in value than negative 7t plus 13. So I see here again one of the big challenges with this inequality is that the t shows up both on the left side of the inequality with 5t and the right side of the inequality with negative 7t. I need to move one of those terms to the opposite side of the inequality so that it can be combined with the other t. I'm going to choose myself to move the negative 7t because adding to me is a little easier than working with negative numbers. So instead of doing minus 5t on both sides to move this 5t, I chose to do plus 7t, which is going to cancel out the negative 7t over there. Over here, if you have 5 variables and you add 7 more of those variables, you now have 12 copies of that variable, or 12 times t. The plus 3 can't be combined with it, so we get 12t plus 3 needs to be greater than 13. That first step now has brought us to something that looks more familiar. All of the t's live on the left side here. So we want to get rid of the positive 3. I can do that with a negative 3. So when I subtract 3 on both sides of the inequality, that cancels out the positive 3, and that gives us 12t in the left inequality. And on the right side, 13 minus 3, the difference between 13 and 3 is 10. So we are left with 12t is greater than 10. And hopefully we're familiar now, whenever we have the 12t or whatever variable it is all by itself, we divide by whatever the coefficient is. In this case, divide by 12. And that cancels out our multiply by 12. 12 divided by 12 gives us 1, so we have 1t. I'm just going to write that as t, like I usually do. 10 divided by 12, if I were to use a calculator, 10 divided by 12 does not come out to an even number, or sorry, a whole number. It gives some kind of decimal. But I can't just leave my answer as 10 over 12. It's okay to leave it as a fraction, but as I see in the directions here, and this is true on Khan Academy and IXL as well, they require or expect that you simplify or reduce your fractions. Here I see both 10 and 12 are even numbers, and for me the easiest way to reduce or simplify fractions, if they're both even numbers, it means they both can get divided by 2. So 10 over 12 is the same exact fraction as 5 over 6. And I got there by realizing they're both even numbers, so I could cut them both in half. 10 over 12 is the same fraction as 5 over 6. So this ultimately becomes t is greater than 5/6, just a little bit less than 1. So t could be 1, it could be 2, it could be anything that's bigger than 5/6. Alright, so that brings us to the end of number 4. That one was built for the one that's called multi-step inequalities. So that's probably the 4th one you see on, or sorry, the 6th one you see on Khan Academy, really the last required one on Khan Academy this week. For our PhD level problem, I would say those are kind of optional each day. We're going to definitely go through it. This helps you out or supports you with one of the extra credit Khan Academy assignments this week, one of the word problems that's built around inequalities. So if on Khan Academy you get past the first 6 required ones, the 7th one is about word problems with inequalities. This one, for number 5, I borrowed from Khan Academy. And these word problems are usually going to have you write an inequality that models a real-world situation and then solve that inequality. So here, for this example, they tell us you have $20 to spend on an Uber ride. They tell you that the Uber ride is going to cost $5 as a flat fee to get in the car, plus an additional $2.50 per mile traveled. So I altered the numbers a bit, but this is how Uber kind of works. You get the Uber, you jump in, and when the car shows up to pick you up, they charge you a few bucks just to get in the car because they came to get you. And then the further they take you, the more the bill increases. So in our case, if we're trying for part A, it says write an inequality to determine the distance in miles that you can ride for $20. And they're asking us to use D to represent the distance in miles, and I'm just going to say miles because that's easier than writing the whole thing out. So the variable D is going to represent how many miles we take this Uber. And I'm going to just start writing and thinking about what's going on with this Uber. First off, when the Uber shows up, they're going to charge me $5. That's the flat fee. The Uber comes out, it gets me. If I'm not going very far, maybe it's just a $5 ride. But then as I travel further and further, they say plus an additional $2.50. But that $2.50 is per mile. Every mile has to be charged $2.50. So I'm going to use this variable here, D for equaling miles, and put that into this inequality. $2.50 multiplied with D, because that's going to stand for the distance traveled, tells me how much extra I get charged. And the $5, the 5 here, is my initial charge. That tells me what I started at. So 5 plus $2.50 for every mile will tell me my cost. And here, I only have $20 to spend. So I need my cost, which is represented by this expression 5 plus 2.5 times D, to be less money or equal to $20. I've got $20 to spend, but I need this cost over here. 5 plus 2.50 times D tells me the cost of my Uber. I need it to be less than $20, or it could be equal to $20 because I have exactly 20. But it can't be more than 20. That's effectively what this says. The cost needs to be less than or equal to my $20. So that's how we come up with the answer for part A. I'm going to go ahead and type that inequality in here. 5 plus 2.5 multiplied with D needs to be less than or equal to, I'll grab that less than or equal to symbol from the toolbar up here, needs to be less than or equal to 20. I'm going to go ahead, since it's money, I'm going to go ahead and put that 2.50 as in $2.50, but you could also have written 2.5. Now, part of the reason we build these inequalities in the real world and learn to solve them is they provide solutions to these real world word problems. In this case, we want to know what is the maximum distance we can travel on our $20. So we're going to try to solve this inequality, figure out what is the biggest number for D that will keep the total cost less than or equal to 20. So first off, we're going to get rid of the $5 fee. I'm going to subtract 5 because I see the variables on the left side of this inequality I want to start solving for, or figure out what is the biggest value I could put in for distance traveled and still be less than or equal to 20. By subtracting 5, I cancel out the negative 5. And what this does effectively, it says 20 minus 5 is 15. So this is helping me realize the distance charges. If I'm spending $5 just to get the Uber, the distance charges for $2.50 a mile can't be more than $15 if my total is going to be 20. So that's really what that subtract 5 helped us see. Now $2.50 multiplied with D needs to be less than or equal to 15. So I want to get rid of that 2.5, the coefficient. I'm going to divide by 2.5. I'm going to divide both sides by 2.5. And you could use a calculator if you want, but I know when I do 15 divided by 2.5, that's really the same thing. If I multiplied them both by 10, it's like 150 divided by 25. So if I do 15 divided by 2.5, which is the same thing as 150 divided by 25, you could use a calculator, but it's going to give you 6, because 6 times 25 gets you to 150, or 6 times 2.5 would get me to 15. So that tells us the distance traveled, the miles, if it's $2.50 a mile, needs to be less than or equal to 6 miles. Because if I travel 6 miles times $2.50 will be $15, plus the original $5 puts me up to my $20. So anything more than 6 miles is going to cause my bill to go over $20. So the maximum distance that we could go there is 6 miles, and that's kind of what that inequality helped us figure out. Pretty cool. So it looks like some of you already actually got to an answer there for number 5 ahead of me, which is great work if you got there. Alright, so that brings us to the end. Like I said, this is recorded. You can go back, you can watch any piece, and I'll get some feedback tomorrow about whether we'd rather host these on YouTube or host these on Zoom, and kind of what's more helpful for you all. But for those of you who joined us live, thanks for helping us out. And for those of you who watch the recording after, thanks for taking initiative and getting this work done on your own. Like I said, this is all designed to help you with Khan Academy. One last thing I want to show you, if you're stuck on Khan Academy, our weekly schedule, which you can find at the top of Google Classroom. So if you go to Google Classroom, at the very top there's a calendar icon that you're going to see in a second. Sorry to be slow there. And this calendar icon, you see it says weekly schedule and syllabus. If you click on that, that goes and that opens up, one second, this weekly schedule and syllabus, which both shows you all of the work that you need to be doing for the week, and then it also provides you with some video links for each Khan Academy assignment. It's very slow loading on my screen, so there we go. On the right side here, you will see blue links, and these blue links take you to a video specifically made for each one of those Khan Academy assignments. So if you're working on your own and you're stuck at all, feel free. I would love for you to use these videos. You can also email me to get support anytime. Thanks for joining us. We'll see you all later. Enjoy the rest of your Thursday.